Our next couple problems have us find the derivative of some composite functions, so we have to use the chain rule. For the first problem, y equals sine squared of x cubed, you've got to be careful. Anytime that I've got a trig function raised to a power, I'm going to rewrite that to avoid making mistakes. Sine squared of x cubed actually means the sine of x cubed quantity squared. So when I do this power rule problem and take the derivative, I've got the derivative of the outside function. So derivative of something to the second is 2 times something to the first using the power rule. Inside stuff stays inside times the inside derivative. Well, the inside function is the sine of stuff function. The derivative of sine of stuff is cosine of stuff. The inside stays inside times the derivative of the inside function using the chain rule. Derivative of the inside function is power rule, and that gives me a 3x squared there. This is the end of this problem since there's really nothing to combine, not really. If you want to go crazy with some properties of trig functions, you could possibly combine the 2 sine x cubed cosine x cubed with a double angle formula, but nobody's going to, I don't think anybody's going to expect that sort of thing. The next one is the derivative of e to the x cosine x. So we know how to take the derivative of e to the x. The derivative of e to the x is e to the x. But when we've got the chain rule, we're taking the derivative of e to the some function. So the derivative of e to the some function is e to the some function times the inside derivative. So the inside derivative is a product, so the inside derivative is a product rule. Product rule is the derivative of the first times the second plus the derivative of the second times the first. Notice here the minus is from the derivative of the cosine, which is negative sine, and that's it for this problem. The only thing that I would probably change in this problem is I would write, we don't need the 1, so I would just write cosine x, and then I would write my x in front of the sine of x function. That's it for these two.